Welcome back. In the last video, we have seen the concept of pulse width modulation, and we have successfully applied it using Arduino microcontroller. We have done is a brute force mechanism. We have changed digital output state from 0 to 1 and 1 to 0 by writing a high and low on the particular digital output with certain delays. Arduino in principle does allow directly to do pulse width modulation with very specific frequencies. There are about 6 pins which are specifically marked on an Arduino microcontroller. If you are using Arduino Uno, there are 6. They specifically represents the pulse width modulation. In these 6, 2 of them work at the frequency of 980 Hz, and the rest of them work at the frequency of 480 Hz. So you can control the duty cycle of the signal, and that is how you use the pulse width modulation to control the digital systems. Now in this video, we use this built-in feature of microcontroller pulse width modulation and control the brightness of a laser diode. We go ahead and see how to do the pulse width modulation directly using the features of Arduino. So if you look at the Arduino, you can see the digital PWM, which is marked with the tilde sign here. They corresponds to pin 3, 5, 6, 9, 10 and 11. So these are pins which can use as pulse width modulation signal out. These are internally configured using ATmec20. Pin number 9, 10, 11 and 3 uses a 450 Hz as a frequency. In the last video, we have seen the frequency which we use is fairly small. In this case, Arduino is giving us 490 Hz. If you want faster, then there are pin 5 and 6 which give the 980 Hz frequency for the pulse width modulation. There is a function given by Arduino developer. All you have to supply is an integer from 0 to 255 to controls the duty cycle. That means if you have a number 0, then duty cycle is 0. And if you have given a number 255, then it is considered to be 100% duty cycle, and it is uniformly takes the value between 0 to 255. So this is how Arduino pulse width modulation works. It is fairly easy to use. Let's quickly look at the code because it involves some of the new function. So we are using pin 11 for the output, that is our digital output, which can accommodate the pulse width modulation. We are connecting the laser diode instead of ordinary LED, which works at 5 volts, so we don't need additional resistance. So in the setup, we need to set this configuration to output, and that is what is done. So laser pin, which is defined as 11, is now set as an output port, and then we can go on in the loop. All we are doing is giving an analog write. So this is a basic function, and then you have to give the pin and number which corresponds to the P cycle, and then we give a delay is to see the signal. This button will be flashed onto Arduino, and we can see it working. By changing this number, we can also see the change in the brightness of a laser diode. Actually, laser diodes are not easy to control the brightness. Now we can control them very precisely in the step of 255 gradation. So let us look at the demonstration. This is our hardware setup where you have Arduino board already connected through the USB cable to my laptop. We have connected a laser diode positive to the pin number 11 and the negative to the ground, which is close by. This is the advantage having several grounds. You can easily use them to connect the external circuit. Now we flush our code. So code is basically is here. You have a laser pin 11 as our output, and we use the maximum power, that is 255 in the analog, right? So that would be 100% duty cycle. Now we flash it on to the board. Now you can see the laser is lit up very brightly. So this is supposed to be the maximum power which you can send it through the pulse width modulation. We reduce it slightly, let's say 200. Let me flash it again. Yeah, maybe don't really see the change in brightness because this laser diode is too bright. And often the idea is to use the laser diode with the lesser brightness for the more simple experiments. On the other hand, real power would be very large, which could be dangerous. Let me reduce it to 25, which is supposed to be close to the 50% duty cycle. So you can see that it has already become very dull. So now you see the dramatic change because we are reducing the intensity. I am making the counts to be 50. So that is 1/5 of a duty cycle. And you can already see it has become very dim. So we can go ahead. I reduce the counts to 10. You can see what happens. It is barely visible now. You have intensity have come much lower. You can see the spot here, that which is become reasonably dull. Now we can put to 0, and this is the 0% duty cycle, and you can see laser is completely off. So this is how you can change the count from 0 to 255 to change the pulse width modulation duty cycle from 0 to 100%. And this is basically what you have is a 0% duty cycle, and your digital signal is basically 0. So this is how you use a pulse width modulation provided by the Arduino board to control various digital circuits. It all works very nicely to control the LED or the laser diode brightness, but we seems to be using two complex devices, such as we have Arduino, then we have a laptop to control them and so on. What would we like to have is a simple setup. We write code onto the laptop, flash onto the microcontroller, and then it should work on its own. In order to do that, we need to have an additional control which can change the brightness or the duty cycle. Now in this case, we are manually entering into the code and flashing it onto it. That's not a very efficient mechanism. If you are an analog expert, you could always use one of the analog input, measure the resistance or the voltage across it using a potentiometer to control the brightness of LED, which is usually done. Now this might seriously hurt your digital art. You don't want to spoil your digital spirit. So what we are going to do now is to control using a simple push button. You have often seen such as volume controller, where you have a single button on which you push on, then it would change the brightness, and eventually it would reach to a maximum and then cycle back to 0 again, go in a round. So this is what we are going to do. For that, we are using one of the digital port as an input and sense whether it is a low or high, and accordingly we will change the intensity of the laser. So we have an Arduino here. We have the pins from pin number 12 to 13. They can be used either as a digital input or digital output. We have already used 11 for the pulse width modulation. Now we are going to take another pin, let's say pin 8. We are connecting it to plus 5 volts, and then we are connecting it to ground. Then we can have a switch which goes between these 2 points, and when it is connected to 5 volts, we consider that as a high, and when it is low, it is 0. Each time when you put high or low, you can change the duty cycle, and for that read the digital input. So we have to set pin 8 as a digital input. In addition, we also have to read the state of a digital pin, and that can be done using the function digital read, and you have to give the pin number. In this case, pin number is 8. Now there is a warning coming with this digital read function of Arduino. It is high or low depending on which state you are, and when it is not connected, it randomly gives you anything. So this is not quite convenient. One need to change the setup slightly differently, because when you switch from high to low, there seems to be a lot of unknown status. You may be changing the switch taking a long time than the fast readout of the Arduino, which may be several thousand times in a second. So we need to accordingly change our signal in order to accommodate this peculiar point of the read function. So what we do is we connect this pin number 8 directly to the 5 voltage with a reasonably large resistance, that is about 10 kilo ohms. So this 10 kilo ohms is usually not high enough to make it ground state. That means that even if you connect pin 8 through resistance to 10 kilo ohm, digital read would still give you an output of high. So idea here is to have another switch, say push to on switch, connecting this circuit from the same thing to the ground. Now what happens when this switch is up, that is not connecting this, when this circuit is open here, Arduino pin 8 is connected to plus 5 volts, which is high. Now when you push this button in, then what happens? This is much easier path to connect, and this is Arduino pin sees this as a 0 because this is a least resistance. On the other hand, there is a 10k resistance between pin 8 and the high. So this naturally takes this route and senses the signal to be 0. If we don't have this resistance, that is called the pull-up resistance, then what happens? When you connect this, it will be immediately short-circuited. 5 volt will be directly connected to the ground, and there is a possibility of you ruining your entire board. So in order to avoid that, you are putting in a 10 kilo ohm resistance. Now because of that, you keep it high all the time till you push this button. Then because of low resistance, you see it connected to the ground at the 0 state. So this push to on can be high or low, and accordingly we can do the programming to change the duty cycle. Let's see how do we write the code. We have a pin 8 which is taken as a digital input. So that is to sense the on and off of the push button. We are connecting laser to the 8, that is as usual, there is no change in that. We are using two more variables. One is called the switch condition, that is to sense what mode the switch is. Another is a duty cycle. I have sent it to high, which is to be bright. So you can change this duty cycle. Usually in a cyclic manner, you keep on increasing. When it crosses the 250, you set it back to 0, or you can decrease it. Then when it becomes 0, again you have to increase. The easier to do, increase it and the reset because of the simple mathematical operation. We are doing a setup in which one pin is set as output, that is where your laser diode is connected. Other pin number 8 is taken as an input, which is connected to the push button. We have a simple loop here that is returns the condition of which, that is through the digital read. So it could be 1 most of the time if you are not pressing. If you press the switch, then it is going to be 0. That means when you press the switch, you want the duty cycle to be changed. Whenever the switch condition is low, increasing the duty cycle by 5. This is a random number, you can use anything. 1 will be too much, there is a tiny change in this. 10 would be too high, so I basically stuck to 5 so that it's not neither too small nor too big. This is a simple code to restrict the number from 0 to 255. That is, you take the modulus, percentage is a C way of taking the modulus. So you can see the duty cycle, %256, restrict variable duty cycle to 0 to 255. You can increase it as many times, but it is still restricted between the duty cycle. Then you write to analog right, where you are send the signal to laser, and then you delay it 100 milliseconds. So again, this delay is just to ensure that switch is sensitive enough. Make it too low in terms of 1 second or 100 millisecond, then it response looks too poor, then you have to keep pressing it several times to change. You might have seen this happening with the remote sensors. When you want to increase volume, sometimes it doesn't respond and sometimes it goes too quickly. So this can be adjusted by this. I have set reasonably so that to have a reasonably smooth working increase of the diode's brightness. Once this code is flashed, you don't need computer anymore. You can simply connect Arduino board to 5 volts or 12 volts. It would work without any problem, and you can, by pressing the switch, change the intensity or the brightness of the LED. Take now your Arduino box to anywhere once you have flashed the code in, and then make it working simply connecting to the DC power supply. This is our setup. We have connected laser from 11 and ground. We also have a push to on switch here connected between pin 8 and ground on this side. I've kept the lead very long so that I'll be operating it from behind, so you will no longer see the push to on switch button. Let us flush the code. See, we have laser fired up. Now I am pressing the key. Let's see what happens. Push to on. You can see that it becomes slowly. I'm continuously pressing it, so it should slowly increase, then bright, and then suddenly becomes dim. And when it becomes 0, and then again it would increase as I press this. And when it becomes 255, it switches again becomes 0. So I'm continuously pressing this. You can do it couple of times, then it would simply becomes bright. And this is how you can use the digital input signal to use an external interface such as switches to regulate the control using the Arduino board. Once we flash this code, we don't need this computer anymore. We can simply disconnect this and connect it to a standard USB power supply, and then this would work as we see it now. This is advantage. You can program your Arduino board, and you can then plug in into any device, and that is why it becomes extremely popular. So these are some of the basics pulse width modulation. We will further do more interesting experiments with either digital or analog, or sometime combining both to control various digital and analog systems.